In the previous sessions, we have seen an introduction about DDA line drawing algorithm, about slope, about the y-intercepts, about the derivation of the algorithm, all these. In this session, we will solve two examples under DDA line drawing algorithm. Consider a line from the point 0, 0 to 4, 6. So the first step in DDA line drawing algorithm is to calculate del x and del y. Del x is calculated by x2 minus x1, which is 4 minus 0, 4, and del y is calculated by using the formula y2 minus y1, which is 6 minus 0, that is 6. Next step is to calculate the value of steps. Value of steps is the maximum of x, del x and del y. So here del x is 4 and del y is 6. So the maximum of this two, absolute value, we need not bother about negative values. Only the absolute values of del x and del y are considered for calculating the steps. So whichever is maximum. So in our case, del y is maximum. Therefore, steps is assigned the value of del y. Then as per the algorithm, we have a formula for finding out the increment value of x and increment value of y. So since this is belonging to case 1 where we have positive slope. So the positive slope is calculated by, the slope is calculated by using the formula del y by del x, which is 6 by 4, which is 1.5. And 1.5 is positive. And here the direction of the line is from left to right. Therefore, it falls under case 1. So under case 1, we need to find out the incremental value of x and y. So as per the algorithm, incremental value of x is given by del x by steps and incremental value of y is given by del y by steps. So that is why 4 by 6, which is 0.66, and 6 by 6, which is 1. So the first step after 0.0, x has to be incremented by the value 4 divided by 6, that is 0.66. So x is incremented by 0.66 and y will be always incremented by 1. So 0 plus 1 will be 1 because the first point is 0. So that is why 0 plus 0.66 and 0 plus 1. So when you round off the 0.66, it will be 1 and this 1 will remain 1. So the next intermediate point to be plotted is 1, 1. The next step is, you should not consider this 1, 1 for the next calculation. This is simply the rounding of value. For the next value of x and y, you have to consider this value of x and y and not the rounded value. I repeat, the rounded value is considered only for plotting the point. But for calculation, you have to use this values of x and y only. So this 0.66 plus the increment, x increment always remains 0.66 and y increment always remains 1. So this 0.66 plus 0.66 will be 1.32 and this 1 plus 1 will be 2. So when you round off, this will remain 1 only and this will be 2. That is why the next point to be plotted is 1, 2. Then from the next intermediate point to be calculated is obtained with the help of this 1.32 and 2. So 1.32 plus x increment will be 1.98. This 2 plus y increment 1 will be 3. So the next point is 2, 3. After rounding off 1.98, you will get 2. So 2, so this 1.98 plus increment of x, that is 0.66, will be 2.64, and the previous value of y, that is 3 plus y increment 1 is equal to 4. When you round off this 2.64, you will get 3 and 4 will remain the same. So the next intermediate point will be 3, 4. With this 2.4 and 4, the next intermediate point is calculated. 2.64 plus x increment, which is 3.3, 4 plus y increment, which is 5. So when you round off this 3.33, it remains 3 only. So the next point will be 3, 5. So we are nearing, because our end point is 4, 6. We are nearing the point. The next calculation will be based on this 3.3 and 5. So 3.3 plus 0.66 will be 3.69. 5 plus 1 will be 6. When you round off this 3.69, it will be 4, 4 and this 6 will remain the same. So since we have reached the end point, we are stopping the calculation. So this is how we find intermediate point between 0, 0 and 4, 6. So the intermediate points that we have calculated are drawn or plotted as a graph, and we have a line drawn. So the line might not be fair enough. Since we have used rounding off, this 1, 1, 2 will be there. So 2, 3, 3, 4, 3, 5. For the same x value, we have two y values. So here also for the same x value, we have two. So this is the disadvantage of DDA line drawing algorithm. Since we are using the rounding off function, there will be deviation from the actual point to be plotted. So we will see one more example for the better understanding. So consider a line drawn from 8, 2 to 2, 6. So you can imagine 8, 2 is something in the right hand side and 2, 6 will be something in the left hand side. So this line is going to be drawn from right to left. The previous example, we have drawn a line from left to right with a positive slope which is greater than 1. So here negative slope. Let us see how the slope is calculated. Initially, we will find out del x and del y. So here x1 is 8, y1 is 2, x2 is 2, y2 is 6 with del x and del y. Del x is nothing but dx. Dx is x2 minus x1, which is 2 minus 6. Sorry, 2 minus 8, which is minus 6. Del y is y2 minus y1, which is 6 minus 2 and 4. So obviously, the slope is going to be negative because slope is del y by del x. 4 by minus 6 is minus 0.61. But here the slope is less than or equal to 1, but negative slope. So we have seen 4 different cases. So this comes under case 4 because we have a negative slope and the line is drawn from right to left. So that is why it falls under case 4. So as per the DDA algorithm, we need to find out the steps. Steps is calculated by using the maximum value of dx and dy, that is absolute value. We need not bother about this minus 6 while calculating the steps because steps denote the number of intermediate calculations that we are going to perform. So maximum of this del x and del y. So maximum of 6 and 4 is 6. So here we are going to calculate 6 intermediate steps to find out or to draw a line between 8, 2 to 2, 6. So what value x is going to be incremented and in what value y is going to be incremented. So x incremented is dx by steps, which is dx is minus 6 and steps is 6. Therefore minus 6 by 6, which is minus 1. So here x is decremented every time by minus 1. Only then we can reach from 8 to 2. Yes, the 8 value, x value here is 8 and y value here is 2. So if and only if x is decremented, we will reach from 8 to 2. So x incrementation is minus 1. So what is the value of y incrementation? So that is given by the formula dy by steps. Dy is 4. 4 by 6 is 0.67. So with these two values, we can find out in what value of x and y we are going to increment. So as seen in the previous slide, we have formula for x increment and y increment. X increment, by using the formula, we have found it as minus 1 and y increment is 0.67. So with this, we will do the calculations and find out the intermediate points to draw a line from 8, 2 to 2, 6. So first point is 8, 2. The second point is 8 minus 1. So that is why we get 7 here. For y, 2 plus 0.67. So that is 2.67. So we need to round off this. When you round off this 2.67, you get 3. So the next point to be plotted is 7, 3. In the next step, this value of x and y should be considered and not this rounded off value. So 8 minus 1 is 7. So that 7 is considered here. this 2.67 is considered here. So 7 again minus 1 will be 6 and 2.67 plus 0.67 will be 3.34. When you round off this, you will get only 3. So the next intermediate point is 6, 3. Next point to be calculated. The next point will be 6 minus 1, which is 5, and this 3.34 plus 0.67, which is 4.01. When you round off this 4.01, you will get 4, and 6 minus 1 will be 5. So the next intermediate point is 4. Again, the next point is this 5 minus 1, 4, and 4.01 plus 0.67, which is 4.68. When you round off this, it will become 5. So 4, 5 will be the next point. Then the next calculation, this 5 minus 1 is 3 and 4.68 plus 0.67 is 5.33. When you round off 5.33, it is 5. So the next point is 3, 5. The next point to be calculated is this 3 minus 1. So always x is decremented by 1 and y is incremented by 0.67. In all the calculation, we should not consider this point for the next calculation. Only the values of this x and y should be considered for the next calculation. So here 3 minus 1 is 2 and 5.33 plus 0.67 is 6 almost. So we need not round off anything here. So the final point 2, 6, the end point is reached. So when we plot again these points, it might not end up in a straight line. Since we are using rounding of functions, it might be deviating from the original fair line. So that is the disadvantage of DDA algorithm. To overcome this disadvantage, we are going to see next line drawing algorithm, which is called as Bresenham's line drawing algorithm, which does not involve this floating point calculations. It only deals with integer calculations and there will be no round of operations, so that you can have a better efficient line drawn. We will see the algorithm in the next session.